So, how does a spark plug work? The business end of the spark plug, well, it starts here at the terminal cap. Sometimes you need to leave this cap on, sometimes you need to take it off, depending on your spark plug cap type. Electricity enters the spark plug here. This part is the lead electrode, the tip or top of the lead electrode. You put your spark plug cap on it. The spark plug cap has a spark plug wire that leads to the ignition coil. Not a lot of current, but a whole lot of voltage is traveling through from the ignition coil through the spark plug wire, through the spark plug cap into this lead electrode here. The lead electrode continues inside and ends here. That's the end of the lead electrode there. Electricity then jumps this gap across here to the ground electrode. This one is the ground electrode. The size of this gap matters. If there is some carbon deposits on this ground electrode and the gap is less than specified, then the electric arc will be shorter and will not be able to ignite all the fuel in the combustion chamber. If the ground electrode bends away and makes the gap bigger, then the arc, the electric arc that jumps the gap, will be weaker and smaller, because the electricity is not going to jump the gap cleanly or as effectively. And with a weaker arc, the weaker arc is not going to ignite all the fuel in the combustion chamber. Electricity then travels through this ground electrode to this threaded part of the spark plug here. This threaded part is in direct contact of the engine. This whole thing is threaded into the engine, and this compression ring provides a seal. You can see that it appears to be folded there, and provides a mechanical seal, so no pressure is lost from the combustion chamber through this threaded part. That compression ring is important otherwise for sealing, but not important for electricity. Electricity from this threaded part, well, actually this whole outside of the spark plug gets energized once electricity reaches this ground electrode. This whole part gets energized, and electricity then travels through to the engine block. The engine block gets energized, but from there electricity is taken through ground cable back to the battery's negative terminal. That's how a spark plug works. Now I cut this one open, that's why it's a little wobbly, and you can see what's inside. You can see that the lead electrode here, its entire length is insulated away with this white porcelain insulator, so it's in no contact with the outer part of the spark plug that is in contact with the ground. This porcelain insulator is very brittle, extremely brittle. These are some parts of it, and it's the same porcelain material that's on a light bulb socket, or you can see the same material on overhead power lines, insulating the power line from the tower. Now, on a spark plug, this insulation that surrounds the lead electrode there should be intact. Sometimes a crack develops due to heat and vibration, and in this case the electricity from the terminal here, from the lead electrode, travels through, and at the gap it short circuits. It goes directly to the outside portion of the spark plug, and then from here to the engine, from the engine to the through the ground cable to the battery's negative terminal. It doesn't ever reach this part of the spark plug and does not provide a spark in the combustion chamber where it's needed. Electricity just takes a short circuit here sometimes. There should be no continuity between this metal piece and this metal piece. They should be totally isolated and insulated away. This concept of continuity I want to demonstrate with these scissors. On the scissors you can observe three metal surfaces: the blade, this part that's used for opening a bottle, and the screwdriver end. As is, we have no way of knowing with the plastic molding in place if this blade is the same piece of metal as that one, or this screwdriver bit is the same piece of metal as that one, or the blade. If I set my voltmeter to continuity, and on this model continuity comes with an audible beep, such as that. Some other models come with a light, that's just as simple as a light bulb, seriously, and a battery. So continuity works this way. On the blade itself, that part of the metal and that part of the metal is electrically conductive. We have continuity, it beeps. Let's see how it works between that chunk of metal and this. We verified now that indeed these two parts of the blade are made of the same metal. Not only made of the same metal, but also continuous, one unbroken piece. How about the screwdriver end? There is continuity. So that means that even though parts of it are insulated and covered with this vinyl, we can verify that that screwdriver bit is a continuous one piece with the blade. Starting at the tip, ending at the screwdriver, it's one piece of metal. Now, back to the spark plug. Again, there should be continuity between the tip of the lead electrode and the bottom of the lead electrode, but there should be absolutely no continuity between any part of the lead electrode and the outside part of the spark plug that's grounded. There should be no continuity between them if the spark plug wants to be functional. Okay, so that's how spark plugs work.